Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about programming tools and languages which are used for designing the embedded system. So before going to this one, we need to give some introduction. Means embedded system design involves firmware design and hardware design. So to reduce the development size, the processing element or core component manufacturer itself, they are providing the tools. So those are used for reducing the development time. If tools are not available, manually we are doing means it takes some time. Like if you need to expert in the architecture of particular processing element, addressing modes, instruction set, register organization, memory organization, interrupts, and all these things. So to improve the speed and reducing the cost, we require more capacity processing element. As technology improves day by day, and we are getting advanced processing elements which are offering high speed with reasonable cost. So as days are going on, we are getting latest processing elements with more capacity and maximum speed and low cost. Every time, whenever the processing element changes, every time we are learning its addressing mode architecture, it takes some time consuming process. Whenever we are expert in that processing element knowledge, then only we can efficiently utilize the memory or resources. Otherwise, it consuming more memory, it consuming more time. So speed reduces, cost increases, memory space increases. So there are some limitations are there. So to overcome that one, even we are getting new processing elements, the same code or same design used for advanced processing elements also. Like that, we are getting the tools. Don't bother about addressing modes and instruction set and architecture, mostly. Okay, we will discuss some of the tools and languages. Language means based on the process is first, which processing element provides the maximum speed with a reasonable cost. Based on the processing element, the manufacturer itself providing the corresponding IDE tools or assemblers or compilers. Based on the tools we are using here, corresponding languages we need to learn. Suppose I want to design the applications on 8051 microcontroller. At that time, the Intel manufacturer providing the Keel Microvision IDE tool. Either fifth one is the current version. In this tool, by using embedded C language, I am designing the applications. Here 8051 is the processing element or core component of the embedded system which are used here. And if you want to design applications in this processing element, we need to use Microvision tool provided by the company manufacturer like Intel, AMD, like that. Okay. If you want to design application in this tool, we need to know the embedded C language. So here we are learning this Keel IDE tool or C languages like that. Similarly, suppose if I want to design applications on TM4C123GH6PM. This is the ARM microcontroller. If you want to design applications on this ARM microcontroller, we require Code Composer Studio IDE tool provided by the manufacturer itself. If you want to design application in this tool, we require embedded C language. So whatever the design user here, the same design also we can use here because it's same language with little bit modifications like IO ports and hardware configurations. No need to learning about architectures and mostly addressing boards and instruction set. Okay. So we will check one by one thoroughly. First, we need to learn about programming tools. First one is assembler. In the beginning days, for designing the embedded system applications or embedded systems based on the processing element, first we are learning the corresponding assembly language like mnemonics. Okay, like suppose I want to design applications on 8086 microprocessor. In that I am using the assembler is 8086 assembler. In that the mnemonics we are using here MOV. Okay, INC, ADD or INT interrupts. These are the mnemonics we are using here for designing various applications. Suppose I want to add two numbers 1 plus 2 equal to 3. If you want to design this adder circuit or a calculator in this assembler, I need to know this instruction set and addressing modes and architectures also. Register organization, all these things. The program is move AL, 1, move BL, 2, add AX, BX, INT 03. Okay, so here assembler is a software tool that converts this assembly language into the machine understandable language like 0, 1, 1, 1, 0, 0, 0, whatever may be, corresponding binary number. This 0 means logic low, 1 means logic high. So assembler is a software tool which converts the assembly language into the machine understandable language. Okay, dot ASM to the dot exe file. This program is saved as dot file name dot ASM. ASM is assembler file. That is converting into the machine understandable language, that is dot exe file. Next, compiler. Compiler is a software tool which are used to convert the high level language program into the machine understandable language. Suppose same application, void main int a comma b comma c, a equal to 1, b equal to 2, c equal to a plus b. Okay, print c comma percentage d. Okay, sample program. Okay, so this is the C language program. This file name is saved as file name dot c is converting into the dot exe like 0, 1, 1, 1, 0 like that. Compile high level languages means like C language, Java language, Python language like that. Compiler is a software tool which converts the high level language into the machine understandable language. Next, linker. Linker links the all necessary objects files and generates the absolute object file. Suppose if you want to design calculator contains addition, subtraction, multiplication, division, and so on. Suppose if you are writing the programs for these individual applications like adder one program, subtraction one program, multiplication one program, each one is converting into corresponding object files. Okay, whenever compiling and generate object files and executable files. So this linker links all these addition object file, multiplication object file, subtraction object file, division object file into absolute object file, finally calculator object file. Okay, so linker links the all necessary object files and generates the absolute object file. And locator, so this generates the locatable address of that absolute object file. So in which memory location we need to store this generated absolute object file. Loader loads this absolute object file into the corresponding memory location. Okay. Next, debugger. Generally, whenever we are compile the program, if any syntax errors are there, we are getting that errors. Some semicolon is missing, some space is there, or some syntax is wrong, like that. That is syntax errors. Even syntaxes are we are clearing, means zero syntax errors, zero errors and zero warnings. But error indicating syntax errors there. Whenever we are getting the compiling, we are getting the errors. That is syntax errors. Even we are getting zero errors, in some cases, we may not get the desired functionality. Like, I am adding 1 plus 2 equal to 3. This is the desired response. In some cases, if I am getting 3.01 means, why we are getting 0.1? So that is the functionality deviation. Instead of 3, I am getting 3.01. So why I am getting this 0.01 additionally? That needs to be found in the program where the deviation is occurred. Why we are getting this additional 0.01 content. Okay. Further, bug means this functionality deviation here. Debug means remove that functionality deviations. How can remove means, in the program, I am setting breakpoint here. Suppose here, I am moving 1 into the accumulator. Okay, here. Whenever executing this instruction, the A value is 1. Before that, 0. What are the previous values are there? After executing second instruction, the B value is 2. After executing this instruction, C value is 3. So I am setting breakpoints and whenever I am pressing the run button, up to this breakpoint only the program will be executed. At that time, I am checking what is the value of A. Next breakpoint. After pressing again run button, I am getting the B value. The A value is 1 or not after executing that one. Or any other values are getting other than 1. You need to check. Like that, wherever we want to check the functionality, up to that we can set the breakpoints and verify the functionality. If any deviation is there, we can modify that point, modify that instruction. Like that, even thousands of lines in the program, we can set the breakpoints wherever the functionality is reflected and find out the functionality deviations and remove that, modify that one as per requirement. That is debugging tools like JTAG, Nexus, in-circuit emulator, RAM emulator. So these are the debugging tools. Okay. In these tools, so there are different tools. I am saying Keel Microvision tool, CC Studio tool, or MATLAB, Xilinx. These are the different IDE tools. MATLAB is simulator, remaining are IDE tools. IDE means Integrated Development Environment. Initially, we are using assembler. After assembler, we are using compilers. After compilers, we are using IDE tools. Why? What is the meaning? IDE means IDE, Integrated Development Environment. Here, integration means combining. What we are combining? Suppose if you want to write the code, we require editor window. We require separate editor to write the program. Next, compiler or assembler to convert into the machine level. Next, we require debugging tool to find out the functional deviations and rectify that. So, if you want to do this operation, we require individual tools. It takes some time consuming process or some burden process. To provide somewhat flexibility, these three are integrated in single IDE tool. So the key contains editor window for writing the source code, compiler for converting into machine understandable language, debugging tool to find out the functionality deviations. So it provides somewhat flexibility to the customer or designer. Instead of using individual tools, we are using single tool. Okay. Next, EDA tools. These EDA tools are used for designing the layout in the printed circuit board. Suppose this is the PCB means in this PCB where I need to fix 8051, where I need to fix RAM, where I need to fix ROM, or where I need to fix I2C or USB, like that, or IO ports, where I need to place. To reduce the accessing time, we need to place this component side by side. So which place provides the shortest path to access the information? That is an EDA tool. Electronic design automation tools. Or say CAD tools, computer aided design. In these tools, first we are using, in the beginning days, we are using assembly language to design the applications like move AX,1, move BX,2, add AX, BX, INT03. In the mnemonics or instructions, we can design the applications. It is somewhat better when comparing with previous ones by writing zeros and ones when comparing with that one. Instead of writing zeros and ones, you can simply learn the instructions and write that design the applications. The limitation is, if you want to design the application using assembly level language, we need to learn all the things like architecture, features, register organization, memory organization, interrupts organization, pin configuration, and all these things, IO ports, and addressing modes and instructions. So as technology increases, day by day we are getting new processing element. Every time we are learning means time consuming process. To reduce the time consuming, we are going for high level language. In Key also we are using embedded C language. In Code Compose Studio also we are using embedded C language. In MATLAB also mostly similar to the C language. Xilinx, VHDL language. VHDL. Very high speed hardware description language. So those are also somewhat similar to the C language. Next, Python, Java, ADA tools. So these are different types of languages that depends on the tool. In case of MATLAB, we are using M script, that is served as .m file. MATLAB file. Or in Xilinx, we are using VHDL language, or Verilog language, or ABC language. Suppose in CANOE IDE tool, this CANOE IDE tool is used for testing the CAN bus, control area network communication bus. Data is transmitting properly, Is there any data loss? Is there any time delay for transmitting the data? All these things will be verified in this CAN IDE tool. In this, we are using CAN access programming language script. This is the language. Okay, these are the different tools and corresponding languages which are used in the embedded system design. So, a programming tool or software development tool is a program that software developers use it to create, debug, maintain, and support other programs and applications. So these are the various tools we are using here. Compiler, assembler, linker, locator, loader, and debugger. So a compiler is a computer software that transforms the computer code written in the one programming language like source language into another programming language, that is machine understandable language. The name compiler is primarily used for programs that translate source code from high-level programming language to a low-level language like assembly language, object code, machine code to create the executable program. The object file is a file that contains a set of machine language instructions and data resulting from language translation process. Machine language instructions are specific to the particular processor. 8086 instructions are different. 8051 instructions are different. The compiler that runs on a computer platform and produces code for that same computer platform is called native compiler. Okay. So same processing element means we are using native compiler. Other processing element design means that is cross compiler. So a compiler that runs on one computer platform and produces code for another computer platform. Okay, that is called cross compiler, assembler or interpreter. In some cases, compilers do not have support to convert into assembly code. Then the program will move to the assembler. An assembler is a software program that converts the source code of assembly language into machine language. It performs one-to-one translation from human readable assembly language to equivalent machine language. The input of the assembler must be assembly language. An assembler that runs on host but produces binary instruction operate for some other target is called cross assembler. The same we already discussed. Linker is a program that takes one or more generated by compilers and assembles them into a single executable program. The linker combines the object files from compiler and resolves variable and function references. Source code may be contained in more than one file, hence it must be combined. The linker creates a relocatable version of the program. Suppose for mobile phone, there are various applications, calculators, gamings, browsing, camera, voice call, or text messages, whatever applications we are providing. So each one contains individual programs. Those needs to be compiled during development stage. Later, we are combining all these corresponding object files and generate the absolute object file. That is done by the linker. A locator is a tool that performs the conversion from relocatable program to executable binary. The locator assigns a physical memory address to the code and data sections within the relocatable program. The locator produces a binary memory image that can be loaded into the target read-only memory. That means that creates the image, executable image that needs to be loaded in the target hardware. Loader is the part of an operating system that is responsible for loading programs and library files. It is one of the essential stages in the processes of starting a program, as it places programs into memory and prepares them for execution. Loading a program involves the reading the contents of the executable file containing the program instructions into memory, and then carrying out other required preparatory tasks to prepare the executable for running. So loading loads the program into the memory space. So we already said debugger. Bug means functionality deviation. D means remove. So remove the functionality deviations. So a debugger or a debugging tool is a computer program that is used for testing and debug other programs like target programs. So these are the various tools we are using here: assembler, compiler, IDE tools, EDA tools, linker, locator, loader. Okay, these are various tools we are using here to design the embedded system. For this topic, we are referring the textbook is Introduction to Embedded Systems by Shivu KV, published by the Tata McGraw-Hill Education in the 2009. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.